So there are a few different sorts we need to know about. If you took IT Launch with me, you probably learned about bubble sort, if you remember. But we are going to also talk about selection sort and insertion sort. So I talked about them briefly last time, but I'm going to go over them again a little bit in more detail. So, yep.
Today we're
whoa, what just happened? I don't want to watch that video again. I want to go through this. Right. So what we're going to do is imagine I wonder if I can, no, I can't do it. So imagine a list of elements, say an array, right? And we need to go from one end to the other. And what we're trying to do with selection sort is pick the smallest one. So if you wonder if it would be easier for me to do it this way. All right. So we have our array. It's out of order. 8 and 5. So is that backwards? Oh, not on the meat. All right. Okay, well, anyway, so what we have to do is we start here, as we always do, with position 0. We compare our one at a time all the other elements of the array. And we have to keep track of the smallest so far and the position of smallest so far. And the reason that we have to do that is because, yeah, 1 is right next to it this time. But, you know, in another example, I might have put 1 all the way over here, and this might be 5 or 6. Let's just make it 6. Right? So what I'm going to do is I know I'm starting at 0, and then I look at the next one to the right. That's 6, a horribly drawn 6. So the smallest so far is 3. Right? It's still 3. We start with the number we're on. Position of the smallest so far is 0. We look at 6, it's not smaller. We look at 9, not smaller. We look at 2. Oh, look, that's the smallest so far. So we change that to a 2, and we change this to position 3. So the smallest number we've seen so far is the number 2, and it's located at position 3. We keep going. 8 is not smaller. 1 is smaller. So 1 is the smallest number we've seen so far. It's located at position 5. And now we're at the end. We can't look at any more numbers. So now we know the smallest number in the entire array is the number 1, and it's located at position 5. So our current position is 0. So all we have to do is swap 0 with 5. So, sorry, position 0 with position 5. So this becomes 1. I really should have used a pencil. And this becomes 3. Now our current position is going to be 1. We move over to the next one. Smallest so far is 6. Position of smallest so far is 1. And we do the same thing. We know we never have to look at this one again. We know that we've moved the smallest number into the first position. So now we start at the next one. 9 is not less than 6. 2 is less than 6. So the smallest so far is 2, and that's position is 3. 8 is not less than 2. 3 is not less than 2. So then we swap these guys. And now this is 2, and this is 6. And then we say current is now 2. So this one is also done. So now we start with 2, and the smallest so far is 9. Position of smallest so far is 2. 6 is smaller. 6, that position is 3. 8 is not smaller. 3 is smaller at position 5. So this guy gets swapped again. And now we have 3 over here and 9 all the way over here. And it actually just so happens that the rest are in order, so there's not going to be any more swapping, but it still goes through. No, that one is swapped. This one checks 8 and 9. Those are bigger, doesn't swap. 8 checks 9. That's done, and then that's done because there's no more to check. So that's how selection sort works. It goes through each position. It sticks one pointer there, checks all the others for the lowest number, swaps them. Goes to the next position, does the same algorithm, checks all the ones for the lowest one, swaps them. Same algorithm, checks all the rest for the lowest, swap, 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 swap. So at each position, it is selecting the lowest possible number. That is how selection sort works. All right. So you get passed in an array of elements. It goes from 0 to the last element of the array. That's the outer loop, right? That's the left hand saying start at 0, 1, 2, and so on and so on and so on. So the outer loop goes one at a time from 0 to the end. The unsorted portion, right, starts at the same place. We don't go back to 0 every time because we know that after the first one, 0 is already sorted. We know that after the second run through that position 1 is already sorted. So we just start our right hand from wherever our left hand is. 0, 1, 2, 3, we start the right hand at the same point and go to the right. So this one, the right hand starts where the left hand is pointing and goes to the end every time. So there's 2 loops here, one for the left hand moving one at a time, and one for the right hand searching every time. And then it says, if it's less, find the minimum index. So at the very end, it does. So this could have an if statement, but it doesn't. It just says you need a temporary value anytime you are swapping two things. So if you're swapping two elements of an array, that's all that temp thing is there. It's like a temporary place. So if you think about position 2 and position 5, let me actually show you this. All right, so say I'm swapping this position and this position. Okay, and this is 3 and this is 5. If I just say, array position 3 equals array position 5, and array position 5 equals array position 3, what's going to happen? If I want to swap those two, right? They're out of order. I found the smallest one. I want to put it in here. I want to swap these two. What's wrong with this logic right here? Yes, Zoe. Both of them will be whatever's in 5. Right? So let's just say, for example, the actual value in here is 10 and the actual value in here is 20. This is going to set this to 10. So now this is 10, and it's going to set this to 10. We've lost the value 20. It doesn't actually swap them. It sets them both to whatever this was. So what we need to do first is create a temp value, then set So anytime you're swapping things, you need to have a temporary holder to put one of the values. There is no way. You can think about it just with two variables, right? If I have a variable x and a variable y, there's no way to swap them without using a variable z. If you can figure out a way to swap them without any additional variables, then you let me know, and I'll get you a PhD in computer science and math. I have like 20 of them in my drawer here, so. All right, so are we happy with selection sort? Give me a plus minus squiggly in the meat of the Googles. Or just a thumbs up, thumbs down, wiggly thumb. We're all good on selection sort. Excellent. Oh, this is an interesting question. So let's look at this. Don't type your answer in yet. Are you going to give me the answer?
No, that's not responsible.
What? There you go. Here's a PhD. Apparently you can do it with math. Who knew? All right, so I'll give you 10 more seconds to figure out the answer to this question. And then you can type it into the chat. The question is, under which condition, that should say which, not what, when you are selecting from a bunch of options, you say which. When you are choosing from a variable amount, you say what. grammar lesson for today in computer science class. All right, so under which of the following conditions will selection sort execute faster? If it's already sorted, if it's sorted backwards, or it will always take the same amount of time. All right, ready to hit enter in your chat? Ready, go. Ooh, we got some A's, some C's. All right, so in the interest of time, I will explain it's always going to take the same amount of time because the algorithm does not know in advance what the numbers are. It always has to check all the numbers for every single position. So this is not one of the algorithms that can take advantage of a pre-sorted data set. All right.
Today we're going to learn insertion.
No, we're not going to watch your video. All right, so let's draw this bad boy. Excuse me. All right. So maybe I should let this guy talk. Just give me a second here.
Today we're going to learn insertion sort. Let's dive right in. We're given this array and we want it sorted in increasing order. Here's what we're going to do. We'll start at the left and work our way to the right, examining each item and comparing it to the items on its left. We'll then insert it in the correct position in the array. You'll notice that part of our array will be sorted as we progress. We'll mark those items with a green background. Let's begin and you'll see what I mean. We start at 2. Of course, there are no items to the left of 2, so we mark it as sorted. Moving on to 8, we compare it to 2 and leave it where it is. Our first 2 items are now sorted. Next, we have 5, which we can see is out of place. We know it needs to be after 2, so we swap it with 8. Our first 3 items are now sorted. On to 3. Again, it's out of place. We swap it with 8 and 5 until it's in the correct position. We're at our 5th item, 9, and I'm sure you can see that it's in the correct spot. Let's move to 4 and insert it in the correct place in the array. And that's it, we're done. Insertion sort is one of the most straightforward sorting algorithms. For your reference, here's the pseudocode. Insertion sort has the worst case time complexity of big O of n squared, where n is the size of the array. For example, when an array starts in decreasing order, you need to swap and compare every single item, which leads to big O of n squared. Thank you for watching. I'd love it if you subscribe. Please post suggestions for future videos.
Oh no, did I present the wrong thing? No, it was okay. Okay. So insertion sort, right? It starts at 1, and then it puts whatever. Let's use the right hand, left hand analogy again. So the right hand is pointing at the thing you want to insert, and the left hand goes through what you've already sorted to find where that thing should go. So in the first case scenario, your left hand is pointing at 0, your right hand is pointing at 1. So the only thing you have to do is if they're out of order, you switch them. Easy enough. From then on, right, the right hand moves 1 over position. The left hand searches until it finds the right spot to put that new number. Once it puts it in, it goes to the next position. The left hand searches for the right place to put that number. Go to the next position, and so on and so on. So here is the Java implementation. Again, you get a list of elements. The right hand this time is the outer loop. It's starting at 1 instead of 0, and it's going all the way to the end of the array. The left hand, right, so we're we're starting at the position of the right hand, and we're saying it might be already where it's supposed to be. But what we're going to do is, while the left hand is less than the right hand's value, go through the array. Thanks. If it gets all the way to the end, that means the right hand's already in the right position. If it gets to a place where the left hand is bigger than the right hand, then that means you got to insert it there. So that's what it does. So here's the same question. Under what condition will it execute fastest? So you can just type that in. We don't have a lot of time yet, so just put it in the chat if you want. Oh yeah. So actually, you know what? There's 2 answers to this. I just thought of this. So the way that they have it in here, the left hand goes down the array. So this is the answer if the left hand goes down the array. If the left hand starts at the other end and moves its way up, then it would be answer B. So I'm sorry, I explained it the other way, but it's the same principle, right? So the right hand is moving to the new number every time. The left hand, in the way they explain it here and in their algorithm, starts right with the right hand and moves backwards to insert that number. So that's why if it's already in ascending order, then that means it's going to find the position right away every single time. All right, I'm not going to do that. So we're not going to do merge sort right now because we do it later in life. I do want to explain bubble sort really quickly. So, because that's what most people think of when they think of sorting. I'm just going to do it in really, really quickly. So the thing really you have to remember is with both selection sort and insertion sort, in the worst case, you have to go through every number and then look at every other number in the worst case. So they're both go up n squared with the number of values that you're trying to sort. Bubble sort, if you remember from IT launch, is a lot like selection sort. I'm just going to put it backwards. So in this case, what we do is we just look at this one and the next one. If they're out of order, we swap. Then we move this arrow. So this is now 8, and this is now 9. We look at these two. If they're out of order, swap. Look at these two. If they're out of order, swap. If they're out of order, so we just look at 2 at a time like this. And what happens is this biggest number eventually bubbles its way up to the top. So the disadvantage of this is that it could involve a lot of switching, as opposed to selection sort, which has to do the same number of comparisons, but it only switches once. Right? It looks through all of these to find the number 1 and only switches once. Whereas bubble sort, switch, 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 switch. And then go back to the next one. Switch, 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 switch. So bubble sort is the one that most people think of initially because it's really easy. You just like look at 2, and if they're out of order, you switch. You just keep doing that till you're done. But the ones that you really need to know are selection sort. So think of it as looking for the right one, selecting it, and insertion sort, which keeps the sorted stuff on your left-hand side. Put insert one at a time into your sorted side, from the right side to the left side. Whew. All right, how do we feel about insertion sort now? In the chat, go ahead and give me a plus, minus, or squiggly. All right, I am willing to do some of the FRQs for chapter 7 and just record them on video. Would that be helpful? Plus, minus, or squiggly? Yes? Squiggly on insertion sort. Yeah, insertion sort's a little tricky. But I would recommend definitely just Googling it and going through a video a couple times, and you'll get the hang of it.